Okay, welcome back. We're doing the mid-year exam 2020. This is criterion 5 and this is question 3. So examine the displacement time graph for the motion shown below. Okay, so we have this one here. Using the axes below, draw the corresponding acceleration time graph for the 12 seconds of motion. Okay, so for velocity versus time, the acceleration is equal to the rise over run. So A equals rise over run in this case. So for this one, so if that's 1, this will be 2, this will be 3, and this one will be 4. And often we just like to do them over the side here. So 1, A is equal to 0 because it's a flat line. 2, A equals, let's see, it goes from positive 3, it goes from negative 3 up to positive 3. So it's a rise of 6 divided by, goes from 2 to 6, which is 4. So it's going to be 1.5. These are all meters per second squared. 3, A is equal to 0 again, and 4, A equals, goes from 3 down to 0 over 2 seconds. 3, so it drops 3, so it's a negative 3 over 2, which is equal to negative 1.5. Okay, so let's draw that in. Again, get a ruler. So for the first 2 seconds, A was equal to 0. Try and get that on the line if you can. That wasn't very good. See if I can do it better without, not an eraser. Hopefully you can do this faster just with pen and paper. And straighter. That's disgusting. Hang on, I'm going to do one more try with this. Let's see. I might actually make it a thicker line for this one. Let's see how this goes. So that looks slightly better. 0 and 2. For the second part, it was for 4 seconds. It was 1.5 from 2 to 6. It is at 1.5 meters per second. So roughly around here. Oh, doing interesting things with the computer. Oops. It's actually quite challenging to draw this on the computer screen. We'll do it 1.526. There we go. So that's good. I don't know why it's got a little dot there. Okay, so that's good. And then it was again up from, so this was from 6 to 10. It was 0. The acceleration was 0 again. Oh, come on. Not sure what it's doing. Sometimes it doesn't like me having a ruler on the screen. Okay, and then finally for the last 2 seconds, it was negative 1.5, so it's down here. Okay, and you can just do dotted lines between that to signify just there is no break. Just go straight between them, and that goes back up to 0 there. Okay, so that's good. Yep, something like that. Use the velocity time graph provided at the top of the page to determine the distance travelled by the object in the 12 seconds of motion. Okay, so the distance is the area between the curve and the graph. So this time for distance, I'm going to use a different color. I'll use red. I'll go back down to 0. So this time we want this one here will be A1. This will be A2. This will be A3. This will be A4. And then we have A5 here. So if it was the displacement, the direction would matter. But since it's the distance, it doesn't matter. So we just need the total area. So distance will equal A1, which was A1 is from 3 to 2, so 3 times 2. 3 times 2. A2 is a half, 3 times 2, because it's a triangle, plus a half, times 3 times 2 plus, same thing again, we go up to 3 over 2, so half times 3 times 2. Then we have A4, which is a rectangle from at 3, it's got a height of 3, goes from 6 to 10, so that's 4 seconds, so 3 times 4. Plus, finally, we have another one of these triangles, so half times 3 times 2. And you can put this in the calculator if you like, or we can just say that we have it's equal to 6 plus 3 plus 3 plus 12 plus 3, and that's equal to 6 plus 9, 12, 24, 27. Okay, 27 meters. That's the distance, so that's not too bad. That's question 3. Okay, so question 4 will be in the next video.